now that we've done the thrilling snail race, let's think through the actual possibilities. So what are the possible outcomes? Well, the possible outcomes are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. But I think it's actually helpful to instead make a chart. So I'm going to make a chart here where I list dice 1 and dice 2 sort of as separate variables. Maybe we'll go something like this, where it's like I can roll a 1, 2, 3, 4, 5, and 6, and where I can roll a 1, 2, 3, 4, 5, and 6. So if I think through this kind of simple dice chart that I've tried to draw, okay, let's think. So if I go to 1 and 1, what score do I get? Right, 2, yeah. And 1 and 2, I get a 3. 1 and 3, I get a 4. And similarly, this next row, 2 and 1, I get 3, 4, 5, 6, 7, 8. And here I get 4, 5, 6, 7, 8, 9. If I roll a 4 and 1, I get a 5. 4 and 2, I get a 6. 5 and 1 is 6. 5 and 2 is 7. 5 and 3 is 8. 5 and 4, 9. 5 and 5, 10. And then the last in the 6th row, 7, 8, 9, 10, 11, 12. So initially, let's think about Isabella's snail. Isabella's pet snail named 7. Her pet snail named 7 had 1, 2, 3, 4, 5, 6 possible ways of being rolled. Out of how many total possible rolls were there? Well, let's think here. This is like the experimental space is under here. So there are 36 possible outcomes, 6 by 6. So there are 36 outcomes. Of those, Isabella had 6. She had a 6 out of 36, or 1 in 6 chance. And I'm just going to do a little bit of this over here. So our 7-roller had 6 out of 36 ways to get their snail rolled, which is a 1 in 6 chance. Which, anyone know what that is? Is a decimal or fraction? I mean decimal or percent? Nice, 16.6 or 16.7%. Nice, 0.16 repeating. Notice how, by the way, I put the bar over the 6 only. It's not that 1 6 is repeating, it's just that the 6 is repeating there. It could be something else. But this case is 0.16666. Okay, and what about instead, we had Noella was the victor. She won. Congratulations, you won the race. Very impressed. So how many possible ways were there to get 6? Well, let's see. 1, 2, 3, 4, 5 possible ways to get a 6 roll. So she had 5 out of the 36 possibilities. That's already lowest terms. Can someone do that on a calculator for me and tell me what the decimal was? I don't think that was the answer. I think it's a different number. Yeah, it was 5 out of 36. Put 1, 3. 1, 3 what? How would it matter? So 8. Okay, so then it's 8 repeating. Okay. 0.138. Okay. It's not repeating?
No, it has like 8 beats and then goes. Well, and then it's a 9.
Oh, it is repeating? Your calculator's just rounding. Yeah, just rounding that 8. I only know that because out of 36, they will all fall under the repeating decimals. Or something. Okay. What about the person who had number 9? Who's got number 9? I think that was Malox. How many outcomes are there with 9? Well, let's see here. 9, you get 6 plus 3, or 5 plus 4, or this 4 plus 5, or 6 plus 3. So there were 4 possible outcomes there. So that one would have been 4 out of 36, 1 out of 9, 0.1 repeating in that one. So you can see how it's kind of just slowly getting less likely as you get further away from that 7. And each roll, you know, that's the likelihood, but then once it happens, it's happened. Now, what's the theoretical probability that Sam rolls off? So now what we do to find this is we just go through, and we know there are 36 in total. So why don't we just count it from the yard? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, this isn't too surprising, is it? 10, 11, 12, 13, 14, 15, 16, 17, 18. I suppose that's not surprising. That what is the likelihood he rolls an odd sum? Well, same as any time you're rolling. Likelihood of odd versus likelihood of even. Well, in this case, it turns out that the likelihood is half as likely. It's 18 out of 36, which is 1 out of 2, or 50%, 0.5%. And it's funny, we did all this complicated math. The question was actually, what's the likelihood of odd? Well, we were able to find a lot more powerful things. And if we were asked instead, like, what's the probability that he rolls, you know, a 5 or a 2? Or that he, you know, there was a question I was thinking of partway through that snail race of, once we got to that point where both Noella and Isabella's snail was one away from winning, there would have been the question of who's more likely to win at this point, right? Because then there was all this experimental probability. Isabella was still more likely to win at that point, but Noella happened to win. You guys must be heartbroken here. Said Noella, you probably need to throw all Good. Perfect. So you get a bit of time now to practice. Yes, I can put up snail race and let it run on loops. You know, you guys can do this battle over and over. But oh, sure, yeah, I'll go back. Yeah, absolutely.